Well, welcome back everyone. In this video, I'm going to cover 2.7 and 2.8. I'm going to talk about a few things, and most of it you'll be able to get through your ZyBooks, which does a wonderful job of explaining and taking you through the course. So the first thing I'll just say is a floating point number is really anything that can have decimal points, such as pi, which could be 3.14, 159, and a whole bunch of other things, where an integer would be something that is a whole number, such as the number of people in a room. And a floating point literal is nothing more than an actual number that is floating point, such as 3.14159. That's a literal in there. So let's take a look at some of the things that we have in here. It says all variables are type double and already declared, otherwise noticed. So what they want us to do is declare a double named person height. So that's very easy. We just type in the double and we type in person height. Now in this particular case, it does not want us to initialize it. However, it is always, always, always a good idea to initialize everything. And of course, don't forget the semicolon. Now, if I do this, in all probability, it's going to give me an error. Let's see if it does. And it does. Because it's telling me I don't have a semicolon, which I do. And it's because it's looking after height, expecting a semicolon there. So let's get rid of these and click on check. And we still have an issue. So why do we have an issue? Because of spelling. So now the third term should be the magic one. And we're good here. So now we have declare a double variable named package weight and initialize it to 7.1. So now we get to initialize it. So what I'm going to do here is I'm going to put a space in, and I'm going to put in 7.1 and then a semicolon. And in this particular case, I believe it will accept the spaces. There are times that it may not, so that's not a problem. So let's click on collect, check, and whoop, we have an issue. So it's saying don't forget the semicolon. So in this particular case, we probably need to do this. We need to get rid of the space here and the space here. And then let's see what's, you know what? That actually is me. Let's go put them back in and let the person with 25 years of experience in C++ actually declare the variable type. Yeah, now I think we have it. Let's try it now. And this looks good. So it has no problem with the spaces here. It did have a problem if I forget to declare the actual data type. Now it's good when I make mistakes. Sometimes I actually make them on purpose, and sometimes I'm just being me. And the reason why I do that is because it allows me to show you how to fix something and how to solve problems when things don't go right. So now we're going to do something simple. Assign ball radius with ball height divided by 2.0. So I'm going to make a mistake on purpose here, and it's going to knock me down. But the mistake is actually following good programming. So let's go and do ball radius equals, and I'm putting in, it's always a good idea, even though not necessary, but always a good idea to use parentheses when you are doing any kind of calculation. Not only does it make it clearer, it can avoid an error by the order of operations not being proper. So we want ball height divided by 2, so we're going to do ball height divided by 2.0. Now notice the 2.0, and that's important because if ball height happens to be an integer and ball radius happens to be a double, what's going to wind up happening is you're going to get an integer divided by an integer, which is going to leave an integer, and the results will not be accurate. So now I have a parenthesis here, and I'm going to click on check and see what it says. Well, it did not like that. So let's remove the parentheses. And let's try it again. And now we have it. But I highly, highly, highly recommend it. Now, they put in the spaces there. So let's just do it one more time. Let's put in a space and make them happy. And we'll do it again, and let's see what happens. And we're good here. All right, so I'm going to allow you to do this here on your own. And I'll go over these with you. So let's take a look at which base statement declares and initializes double bear. Well, this here is illegal. You cannot do that unless something's changed in the last day. So I'm going to click on it. It should tell me you can't do it. And it did. So percent sign can't be. Percent sign is actually an operator called modulus. So this one here will actually work, but the problem is you'll get a compiler, either a warning or an error saying that is possible data loss, because now you're trying to put an integer into the double. So let's just go and say this is what it says. Although not an error, little should have a fractional part. So this here is the answer, and it's good because then you know for sure that it's a double. And then let's do this here. Which statement best assigns a variable? Both are typed double. So this one is really okay, but it's preferred to do so you have a double with a double. And scientific notation can be a little bit challenging. So I am going to show you a few little tricks in here. So let's see what it says. We want to know whether it's be a double or an int. So let's go, and the number of cars in a parking lot is always going to be an integer. Current temperature should always be a double in Celsius. And then you can work on these on your own to see what they are. So floating point divided by 0. I really want to go over this here. So remember, you cannot divide by 0. That's just not possible to do. I know you might think it may be 0 as the answer, but it's not. So we have 13 divided by 3. So if this was an integer division, if it was just plain 13 divided by 3, not 13.0, you would get a flat 4, because it would trump off the 3333. But because we're doing 3.0, we're doing a double by a double, we're getting, oh, I meant to do that. That was error. So we're getting 4.3. That looks good. So now we have 0 divided by 5. Now you can have 0 in the numerator. That's okay. But remember, 0 divided by anything with the exception of 0 is going to give you 0. And that makes sense. So now we have 12 divided by 0. Well, that really makes no sense at all because you don't know what you're dividing. So it's obviously, you know, it can't be 12 because it would be 12 divided by 1. But however, we have positive or negative. And to be honest with you, I don't see why we need a positive or negative infinity because we really can't use infinity. So we're going to go with positive because this is positive and positive. And let's click on positive infinity and there we go. But infinity is really undefined, so we don't have to worry about that. So now we have a dilemma. We have 0.0 divided by 0.0. Well, we know that can't be 0. And now we have infinity. Well, so I am claiming that this does not exist, so we're going to use not a number, and let's see what's happening. So we're good here. So the rest here is we're using iomanip to set precision. So what we want to have here is which manipulators are used to set C out to 2 digits. Now, a lot of people think that it's just strictly set precision. And this is why I'm taking the time to go through this stuff so that you read and thoroughly understand. In order to use set precision properly, you want to have at least one fixed statement in here. And then you can have set precision. You can change set precision, but you only need one set fixed. And we're going to click on this and see how that works. And what is the output of this fixed and set precision 1? Well, this means just one decimal point after, or one thing after the decimal point, so it should be this. All right, so this takes care of this, and you can work on the rest of this on your own. So now we're going to have scientific notation. So I'm going to show you a few tricks. And I'm going to make a few mistakes on the one with the 7.2. to show you how you fix it. So we have 0. We have 1 point E as 4. So this is the way I do it. This really means E, you want to move the decimal point over 4 times. So the way I do it is I will type in 1.0. And what we need is move the decimal point over 4 times. So I'm just going to go and put 4 zeros here. And then I'm going to move the decimal point over. That's 1, 2, 3, 4. And then we obviously don't need this decimal point here. So now I'm going to do something. I'm just going to delete this 0 here. And it should give us an error saying you should put the 0 here. So let's see what it actually says. And it doesn't like it. It wants the 0 there. So we go back and put the 0 ahead of time. So now we have 7.2 e to the 4 is a floating point with a single. Actually, let's go back and fix that. Then we have 7.2 e to the 4 is a floating point with a single digit before and 5 digits after. So a very common thing to do is put in this and just as 5 digits after. 1, 2, 3, 4. That's 5. So now we're going to get a whole bunch of question marks. And then I'm going to show you the easiest way to do this. So let's go and click on check, and it did not like that. So we're going to do basically the same thing. So we have the 7.2, and we need to go back 4. So 1, 2, 3, 4, and I'll add another one just to be on the safe side. So now what we're doing is we're moving the decimal point over 4 more times. So that's 1, 2, 3, 4. We're going to put the decimal point here. We're going to leave the leading 0 there. And we need to get rid of this decimal point here. So now we have a single digit before the decimal point and 1, 2, 3, 4, 5 after. So let's see how we did. And by golly, we have it. So these are just more practice for you, so I'm going to let you to do this. Now, this one here is really a lot easier than it makes it out to be. Don't try to change anything here with G. Don't try to change anything here with M. Just use G and M. So basically what you're doing here is acceleration of gravity, which is this, equals, and then notice the parentheses here. So basically you're just doing G times N. Don't worry about what all this nonsense is here. Don't worry about this. Don't worry about anything else. Just worry about G and M. And so once you get done with that, you are good to go. And that is everything for this section right now. So I will pick back up with constants. Just remember, constants are your friends. So have a wonderful day. If you like the video, please put a like there. Please put any comments, suggestions that you might have. That will help me to make videos that are more relevant to what you're doing. Have a wonderful day and enjoy yourself.